NEF is a great, the global gathering was really amazing because you meet a lot of people around and had already a lot of inspirations from different people for different type of projects, including mostly related to the scientific, like the community of scientists we are trying to establish. So there is a huge will from the fellows, ambassadors trying to really get connected and do much more than what has been done in the last 2 years. So that's really inspiring.
Speaking about reforming curricula, there can't just be one input or one intervention. It has to be cascaded and it has to be coherent. So policies from the national level that trickle all the way down. And I'm happy that we're speaking about households, about carers, parents, because when we look at the indicators, we know that the education sector can't do it alone.
In 2016, I took a giant leap away from the Curie Institute and launched a platform called Made in Africa. Our very first mission is to map every African scientist and health professional on the planet.
Science tells us that we are all scientists. Even kids are scientists. Science is fundamentally about making observations, developing hypotheses to explain what we observe, and conducting experiments. And kids do this all the time. So I think we need to learn, first of all, understand that our kids are scientists, and then learn to identify the kinds of things that they do in fundamentally scientific ways and try to encourage them in that direction.
I'm a cosmologist and I study this beautiful map, and this is the cosmic microwave background map from the Planck satellite, which is a European Space Agency satellite. I'm a part of it. This gave us most of the information we know about the universe.
I'm not just an academic doctor, I am an Earth doctor. And as a computational seismologist, I unlock the information digitized on ever-increasing, globe-encircling seismic sensors that have been listening to our Earth shaking.
Et ce qui m'intéresse comme application, par exemple, c'est les systèmes d'irrigation intelligents dans les zones rurales en Afrique. En Afrique, l'agriculture reste encore l'activité économique principale. Et pour cela, ce que nous proposons, c'est d'utiliser un réseau de senseurs qui est les senseurs distribués au niveau des farms. Et en ce moment-là, on pourra collecter les données au niveau de ces champs et en utilisant des transmissions de courte distance et qui sont plus précises. Ces données sont envoyées à un microcontrôleur et des décisions sont prises.
I use game theory as a tool that could be potentially used in some of the things that we are developing for the future. Those include energy systems, transportation systems, and wireless communication.
We developed an AI-powered platform, including incremental learning, knowledge, so that we can extract data for the knowledge-based data sources, including literature and so on. You can use it in monitoring pathogens in the biodiversity and also studying biodiversity, and also in maximizing production in different industries.
My colleagues and I at IBM Research have been trying to develop intelligent systems that can financially profile people, individuals who typically don't have any access to financial services. This solution has been deployed with a bank here in East Africa, and it scored close to 2 million people. These are people who typically didn't have any access to financial services.
What if there was an intelligent device that could accurately detect malaria? A device that could connect the expertise to the need in an affordable way. We have just filed a provisional patent for a rapid, affordable and non-invasive device that can accurately detect malaria.
J'ai découvert une toute nouvelle enzyme, une première depuis des années 60. Cette enzyme, appelée glycérol 3-phosphate phosphatase, jusqu'alors méconnues chez les cellules des mammifères, elles joueraient un rôle clé dans l'élimination des effets toxiques du sucre. En effet, quand le glucose est anormalement élevé dans nos cellules, il se forme ce qu'on appelle un glycérol-3-phosphate qui vient du sucre. Et quand il est anormalement élevé, il peut causer des dégâts au tissu.
Nanotechnology is based on the use of nanoparticles for the treatment of diseases. And what's unique about the nanoparticles is that they are very small in size and they have so much unique composition that they are able to be uptaken to the cells and give a tremendous effect. What's even more promising about my research is that within those nanocomposite particles, I'm loading, or we are actually doing research on loading natural compounds within these composite particles. Our composite particles are clinically relevant. They have been successful in the treatment of basal cell carcinoma, in the treatment of psoriasis, and in the treatment of skin fungal infections.
Humans and animals lose tissues and organs due to several reasons, including congenital defects, diseases, and trauma. Africa is about to take a giant leap in terms of regenerative medicine. This is because my colleagues and I in our laboratory, we have been able to come up with ways or strategies that can create tissues and hopefully in the future, organs that can be used for transplantation.
My competence, my background with ancient DNA is unique competence in the region. I felt I had a responsibility to come back to Tunisia to help and to adapt my knowledge to the Tunisian context. In addition, we perform multidisciplinary investigations of type 2 diabetes and metabolic syndrome, based on the integration of various data, including clinical, genetic, nutritional, and microbiotic characteristics.
I am an electrochemist. In electrochemistry, we use electricity to run chemical reactions, or we manipulate chemical reactions to generate electricity. My approach is to emulate breathing to create hydrogen fuel cells. We have successfully emulated the active center of photosystem 2, nature's enzyme for producing oxygen, to create cheap catalysts for oxygen for water splitting. We have built an integrated system which combines two units. In one part, water is fed into an electrolyzer where it is split to produce hydrogen, exhaling oxygen, just like the trees do. In the other part, we feed hydrogen into a hydrogen fuel cell. The cell inhales oxygen from the atmosphere the way we do, generating electricity and exhaling water.
I'm very fascinated about nanoscience and nanotechnology because it gives us the tool to fundamentally change the property of material to create functionality that can be used to solve some of the most challenging problems that our world faces today. Actually, sometimes it gives you ability to even see unexpected things. So what you see here is just material, this same metal hydride, and if you at the top you see that they all have the same color. Okay. And now when you expose it to hydrogen, what you see is that there's a color change, and this color change depends on the amount of hydrogen that you have there. We're able to create, the first, sensor that can actually detect hydrogen just by color change.
I am adopting these biotechnology advances in my own research, and I'm investigating plant resilience. More specifically, I'm working on forest trees. So what if, within this network, we can identify key points to manipulate? And we can do that knowing these molecular switches. Biotechnology, and specifically genetic modification, can spark some uncertainties, some fear. But like those forest trees that I'm working on, we should be resilient.
What do we need to do to make more women in STEM? And the answer is often just to get out of their way.
Yes.
Just remove the obstacles and don't worry about who you're removing them for. If you remove the obstacles, then you will also help Black women in STEM, who are possibly our biggest, most marginalized group. We don't necessarily need help, we just need space.
We have a long way to go still in achieving gender equity, but we have come a long way in STEM, in the STEM field. We can't afford to just sit back, whether it's industry, whether it's policy, say, well, let's see who comes through and then we'll just work with that. We are invested, and we should be more invested in looking at new kinds of partnerships that are invested in really finding and nurturing these hidden talents that are often stifled.
One thing that we want to do as a Next Einstein Fellow is to show that this type of hands can also do art using mathematics and contribute to our knowledge as a humankind. As we think about the future of Africa, we should never forget the best part of Africa. The best part of Africa is not our mine, it's not our diamonds, it's our people.